Wooden block of weight W rests on a horizontal rough board. Rough board means there will be a force of friction. Okay, I'll explain you that how the force of friction comes into existence. Okay, what is the reason for that? The end of the board is then raised up to an angle theta. We have dealt with such questions until the block slides down the plane of the board at a constant velocity. So you just imagine a situation that there is a table, okay, and on the table, let's say your mobile or mouse, it is kept, okay, only that thing. And now you're trying to tilt that table at a certain angle from one side till the time that mouse or that object starts moving. Okay, initially the object will not move up to a certain angle. After that, it will start moving at a constant velocity. Can you guys visualize that scene? A table or a block, anything it can be. So the reason for that is that initially there will be a force of friction. Now you have to understand one thing, that friction is a resistive force. Resistive force means it is a force which resists the motion. Okay. Friction is a force which comes as a reaction. Friction will never come on its own. Okay. Like when we deal with any random person, we always have that type of mindset that till the time you're not doing anything, I will not do anything. But as soon as if you pinch me or if you do something to me, then I will not leave you. So your reaction is triggered by the other person's action. The same thing happens with friction. Okay. Till the time an object is kept, there is no problem. But now what we are doing, we are trying to tilt this block, okay, means this board. And if the angle will increase, suddenly or gradually, I can say that block will have a tendency to go down. Now the friction force comes into existence due to interlocking between the two surfaces at molecular level, at atomic level. Now the best and the, what we can say, the simplest way to make you understand that is that when we see a flat surface, we actually see that by our naked eyes. Now you might have understood that a naked eye cannot see everything at atomic level. Actually, it can't see anything at atomic level. It can just see up to a certain, we can say, size. Okay, after that, we cannot see any microorganism, any virus. I'm talking about that level. Okay, so at atomic level, the surface which looks like this is actually like this. Okay, now this roughness depends on the surface. Let's say if you're polishing the surface, if oil is spilled on the surface, then this roughness will reduce. But if there is nothing, then it will be more. Okay, we have seen different types of surfaces and we can very easily relate that what is the meaning of rough surface or smooth surface. So rough surface will have these type of structures more, smooth surface will have very less. Okay, now comes another body whose surface at atomic level is also like this. Now just imagine that when a body is kept on this body, when two surfaces are in contact, what will happen? These zigzag will get interlocked between each other. And because of that, the body resists the motion up to a certain extent. Up to a certain extent means, if we go back to the diagram, this block will not move up to a certain angle. But as soon as the angle increases further, the block will start moving. So that interlocking is now, we can say that it is getting weakened. Because of that, the block will now move. Okay. So I can say that the force of friction always exists in the opposite direction of motion. Now, where is this block actually moving?
It's moving down.
It is moving downwards. As we can see that if you increase the angle, the tendency of this block to move will be downwards. So now the force of friction will try to oppose that, and force of friction will be applied in this direction, backward direction. So the only thing is that there will be one more extra force which will be applied on the body. Okay. Now, before continuing this question, I will take you back to that inclined plane which we have discussed. We have drawn all the forces for an inclined plane. Let us understand that. So this was an inclined plane, and on the inclined plane, we had seen that this is mg cos theta, and this was mg sine theta. I hope everyone remembers how it was written. Okay, the angle was theta. Because of that, the weight will act vertically downwards. In that question, they have written mg as w. Okay, so whether you write w or you write mg, it is same thing. Okay, so I told you that mg is a force which is helping this block to move down. So if this block has a tendency to move down, the friction on this block will be in which direction? Backward direction. So now if I look at this frame, in this frame, what is the net force acting on the body? Mg sine theta minus f.
Yeah.
Okay, because mg sine theta will provide this block certain speed, but the friction force will reduce that speed. So because of that, the net force acting on the body will be reduced. Mg sine theta minus f. So this net force earlier, which was mg sine theta, now it will be mg sine theta minus f. Now you cannot eradicate friction, you can always reduce it. So because of that only people invented wheels. You just imagine that earlier, during early age, when the prehistoric, whatever we call that man, that early man, okay, they used to drag their carts without wheel. Then they realized that if I put something like that, the circular structure, which later they started calling it as wheel, then the dragging will become easier. Can anyone tell me that what is the reason that wheel will ease down that dragging process? What is the actual reason for that?
So the
The
friction
surface area.
Friction?
reduces.
Okay.
The surface area like in contact with the
Very
ground.
good, very good. This is the more appropriate answer. Both the answers are correct. Friction will reduce, but why it will reduce? Because friction is a contact force. Okay, friction. There are various names given to friction as per the situation. So it is a contact force. More will be the contact. Now, just imagine that if you are rubbing your hands like this, the whole hands, the whole palm are in contact with one another, versus if you rub like this, then there will be only this much portion. Okay, so means you will get a feel that when you're rubbing like this, it is much easier as compared to rubbing like this. Okay, it is all about you have to observe. Okay, so when we are applying wheel, so the surface, the contact between the actual surface and that body will be less. Because of that, the body will be able to move easily. Okay, so before wheel, they might have invented something like this, that let's say if this is a block, so you just apply small stands on that. Now just imagine a wardrobe. Okay, a wardrobe do not have any such stand. Just imagine a wardrobe which do not have any such stand at the bottom. It will be very difficult to even move that wardrobe. Versus if it is having some stand at the bottom, then it will be comparatively easier. And if it is having some wheels, then it will be much easier. Okay, so is that clear? It is all about friction. So friction will act in which direction? Backward direction, and that will eventually reduce the forward force. So that will affect the net acceleration of the body. Now, this much knowledge is enough to understand the question. Let us see what they have given. The end of the board is then raised to an angle theta. The block slides down the plane at a constant velocity v. Constant velocity v means there is no net acceleration. Okay, is that clear? There is no net acceleration. So which row describes the forces acting on the block as it slides down the board? Now let us make the free body diagram of this. So this is mg. They have used w, so I am using w only. Okay. This will be w cos theta, and this will be w sin theta. I have told you that friction will act backwards. So the net force acting on a body will be how much? W sin theta minus F. Is that clear? Now, if you see that frictional force on the block and the resultant force on the block, these are two different things which you have to find. This small f is the frictional force, and that will be equal to F net, that will be the resultant force on the block. Now comes the most important part of the question. If you read the question, they're saying it is moving with a constant velocity. It will challenge all your previous knowledge, which you have done in your lower grades. What is the meaning of constant velocity? Will there be any acceleration in the body?
No.
Everyone is clear with that? There will be no acceleration
Yeah.
in the body. So can I say that F net is actually equal to 0? Okay, because there is no acceleration, and as per the second law, we know that force is equal to mass into acceleration. So if there is no acceleration, means F net will be equal to 0. So 50-50 options is applied now. Okay, so answer will be either option A or option C, because resultant force on the block is 0. Is it clear?
So what do they mean by resultant force on the block?
Resultant force on the block means, if you look at this block,
Yes, sir.
what is the net force acting in this yellow box which I have made?
Mg sin theta minus F. So
Yes, so that is the resultant force.
okay.
Okay. Now, if a block is moving with a constant velocity, means there is 0 acceleration.
Yes, sir.
Acceleration is 0, then ma will become 0. So F net on the body is 0. There is no force acting on the body. It is just moving.
Okay, yeah.
Clear? So I
Yes,
will
sir.
equate this to 0, and that will give me the value of F as mg sine theta. So my frictional force is actually equal to mg sine theta. Okay, so logically
basically,
speaking, if that
there's
is equal to mg sine theta, the block will just have a tendency to move, but it will not move. Okay,
okay, yeah.
all
So
right. Yeah, one more
essentially,
thing.
there's nothing like pushing the block. It's just moving, right?
Yeah, it's just moving.
Okay.
It's just moving because you have created a tilt in that horizontal plane. Okay, because of that. So the answer will be frictional force on the block. I will solve this. F is equal to W sine theta. So that will be the frictional force, and resultant force on the block is 0. So these are the two answers. Okay. Now getting the answer is a different thing. You should understand how it is being done. What is a free body diagram? What is the meaning of constant velocity? If you know free body diagram, if you miss this part, this is a very important part of the question. Constant velocity. Then you will not do acceleration as 0, and you may get net force as W sine theta minus F.
So because the velocity is 0 and acceleration is 0, the friction will be 0. Otherwise, how else will we get W sin theta minus?
Constant velocity. It is not 0 velocity.
Okay.
Constant velocity means, what is the formula of acceleration? It is change in velocity upon time.
Yes, sir.
Okay, so if velocity is constant, then v minus u will be 0, because both of them are
Yes,
same.
sir.
So acceleration is 0. If acceleration is 0, then force will be 0.
Yes, sir.
Force on the body is 0, so I will say that W sine theta minus F is 0. Okay, it is connected, each and everything. Okay, any other doubt, any other question? Okay, moving on to the next question. Now, how many of you knows the third law of motion?
Every
So
action
is
has
it
a
every action or something? equal and opposite reaction.
Okay, now every action has equal and opposite reaction. How it will be applied? Let me first show you through some examples, and then we will attempt this question. Third law is very simple, that whatever you do, you will get back in return. Okay, simple. No one is Gandhiji over here. If you slap someone, you will get the same. You may even get harder. Okay. So if it is harder, then the other person will hit you again. Okay. So this is how it starts. The point is, third law says that action and reaction are balanced. Okay. So the best example for that is, let's say a block is kept, a mass is kept on the Earth's surface, and it is just kept. It is neither going in, it is not sinking in, and it is not coming out also. It is just kept. Just visualize that situation. Now, what is the reason behind that? The force with which it is pushing the ground, which is mg, is balanced by the force with which ground is giving the reaction, which we better call it as normal reaction. Normal is a reactive force which comes as a reaction when two bodies are in contact. Okay, so the point over here is that ground is stable enough to provide the same force mg. Because of that, this block is not sinking in. Now, instead of this hard surface, this is, let's say, cement. Okay, now instead of cement, you take a surface of sand. Okay, go into any sand dunes and try to walk over there. So as soon as the body will push that sand surface, it will start to sink in, and it will sink up to a certain level till the force is balanced. So let's say the force is balanced after sinking this much. So I can say that this mg is balanced at this level. Okay, and that normal reaction, I'm taking it as n1. This is not the same normal which is written above. So the point over here is that whenever any body is applying force on another body, okay, body A is applying force on another body, B will also apply the same force on A. This is what we call as third law, action and reaction. It is applied everywhere. Wherever this action and reaction are not balanced, as a result, there will be some mishappening. Like you try to walk on water surface. Why you cannot walk on water surface? Because the water surface cannot provide you the same normal reaction. Whatever is your force, it cannot provide you the same normal reaction. But just imagine that you cannot walk on a water surface, but a ship, which is 1,000 times heavier than your body, can very easily float and run and we know what on the water surface. How? Any water body is there. Okay, you can take an example of creek. Okay, in creek, you might have experienced that that particular region is not of that depth. Means the water depth in the creek is not too much. Okay, it is a man-made, like a reservoir. Okay, which was just like a mode of transport in earlier times. Now it is just like a, still it is mode of transport, but it moreover acts like a heritage. Okay, it is not used to that level. So if a very big ship like Queen Elizabeth, okay, have you heard of this Queen Elizabeth? There's one ship whose name is Queen Elizabeth. Okay,
Yeah.
a very big ship goes into creek. Okay, do you think that it will be able to float or it will sink?
Yeah, I'll be able to float.
Okay, so the reason
Yeah.
for any object to float on the water surface is the upthrust. Okay, this boat is putting a force in the downward direction, which I can say mg, while the water is providing upthrust in the upward direction, which we can call it as u. Okay, Upthrust is also called as force of buoyancy, and you might have heard of Archimedes principle. Archimedes principle, anyone?
Yes, it's of
It is there
whatever
in
mass that's
CBSE.
put in. Yeah, whatever mass that's put in, the same force is written, or something like that.
It will be like that.
The amount of water that's displaced is the same as the water that is.
So basically what happens when you are putting anything in the water body, okay, there is certain amount of water which is displaced from its position. Now that amount of water will try to regain its position, and as a result, it will create an upthrust on that body. Because of that, the body will float if there is a possibility. Okay, if there is no possibility, then body will sink. So if Queen Elizabeth is if we try to run Queen Elizabeth in creek, okay, it is not possible. The water in creek will not be able to give that much upthrust, because of which the boat or that ship should float. So as a result, the mg of ship will be more, the upthrust will be less. So as a result, the ship will sink. Okay, so the same logic is applied at all the surfaces. And now I think you are ready to attempt this question.
Yeah, I think it'll be C.
I'll wait for others' answers also.
Sir, I think it's C as well.
Weight of the book and reaction force from table surface. Gravitational force of the earth pulling the book, gravitational force of the table pulling the earth. Okay, book and table not applied. Yeah, read C once again.
So I think you said that there's no force or something acting on it.
Okay, just read B again. In B, it is given gravitational force of earth pulling the book, gravitational force of book pulling the earth.
So, but does the book pull the earth? I don't think it does, right? Or
Yeah, if a book is kept on the earth's surface, na, the force with which earth is pulling that book will be equal to the force with which the book is pulling the earth. If they are not
okay.
equal, let's say earth is pulling the book with more force, book will
Yes.
start sinking in.
Uh, okay,
Okay.
it should be B then.
And the vice versa case, book will float or book will just fly in the air. Okay. Third law seems to be most easiest law, but when we talk about such questions, this is the most confusing law, where you have to be very prompt in understanding the forces. So as of now, B looks to be more convincing option. Let us see option C. Weight of the book and reaction force from the table surface. Weight of the book and reaction force from the table surface. Okay. Weight of the book and force of book on the table. Are you guys convinced that this cannot be the answer? Let us cancel the options and then we'll talk about the most confusing ones. Is option A clear that it will not be the answer?
Yeah.
Weight of the book and force of the book on the table, it is same thing.
Yeah.
When we say book is kept on the table, it is putting mg, and this is the same force which it is putting on the table. So they are not equal and opposite. Gravitational force of the earth pulling the book. Let's say this is earth and this is book kept on the earth. So this is mg and earth is putting some normal reaction. So gravitational force of the book pulling the earth, which is mg, and gravitational force of the earth pulling the book, which is n. They are equal and opposite. That's why book will be kept on the earth's surface. This option looks to be convincing. Moving on to the next option, weight of the book and reaction force from the table surface. Now, the biggest misconception over here is they're just talking about weight of the book. It is not given that where the book is kept. Okay, so weight of the book and reaction force from the table surface. If you look at the first option, weight of the book and force of book on the table. Reaction force from the table surface does not specify that it is reaction force due to what. You have to catch that word. Okay, try to read it twice, thrice. You may get that, because that is the only way with which you will identify it as a wrong option.
Sir, in option B, you said that mg is the gravitational force of the book, right?
Gravitational force of the book pulling the earth. Yes.
So shouldn't it be n then? Because
Okay, look. mg is applied by book on the earth. So gravitational force of the book on the earth.
okay.
Okay, mg is applied by you, the body. Okay,
Yeah.
on whom? On the earth. The next one is gravitational force of the earth. So as a reaction, which force earth is applying on you? That is n. So
And
n is a force applied by the other body, that is earth, on the book.
okay, yeah.
Okay, option D also let us read. Gravitational force of the earth pulling on the book. Gravitational force of the table pulling on the earth. So book and table, like, there's no connection. Okay, so D is very clearly, it is a senseless option. We can say that A and B are comparatively more closer, okay, but still if we'll go deeper, B will stand out and B will be the correct option. Okay, before moving ahead, I'll send you the explanation of all four options. Okay, all of you can access WhatsApp right now.
Yeah.
Okay, I'll
Yes.
just send it in the group only. So just read it, and if there is anything you couldn't understand from there, you can ask again. Okay, if there is any doubt in any of that explanation, you can ask again.
Okay, so yeah, this really makes sense. The same type, opposite in direction, and equal in magnitude. Understood. Yeah.
Okay. Shall we move on to the next question? Rajveer, any doubt?
No, sir, all good.
Medicine?
No, sir. Got it.
Okay. So the next question. We did a similar type of question. The last question of the previous class was of pulley. Okay. Read the question first, then we'll do it together. Okay. You have to just observe. So an object of mass m is connected via a frictionless pulley to an object of mass capital M, okay, where m is greater than m. Capital M rests on horizontal surface with a friction force F. Now, what is the acceleration of the system?
Maybe it's lowercase m.
It is
So sir, we discussed earlier, um if an object is just on a surface, then the force would be, the acceleration would be 0, given that v is constant.
okay. That constant v will be considered only when it is given in the question.
Yeah, so here it's not given, so we can assume
Yeah,
that a.
here it is not given means we will consider that there is an acceleration in the system.
Okay, so
Okay.
option A is out.
Hmm. Okay, how we have to think? This whole system will have a tendency to move in which direction?
Downwards and right side.
Like this.
Yeah.
Okay. Is there any doubt in understanding this?
No, sir.
Okay. Now this acceleration will carry forward in the whole system. So I can say that if the acceleration is over here also it will be A. Is that clear?
Yes,
Yeah.
sir.
Point number 2. Whenever we have string, we have tensions in the string. So the force which is there in the string is called as tension force. Okay. I'm just trying to make the free body diagram of the whole system so that you can understand. So whatever I'll be writing with pink color, these are all forces applied on different masses. Pulley is frictionless, so there is no friction on the pulley. So we'll consider no force on the pulley. This is mg, with which this means the weight will be mg, and this one will be force of friction F, because it has a tendency to move towards right, so frictional force will act in the left. Okay. The weight of this block mg will be downwards. It has no contribution in the motion. Since this block is kept on the horizontal surface, so this mg is not contributing in the forward motion of the block. So these forces are just like as a time pass. Okay, these are not helping this block to move forward. Till here, is there any doubt?
No.
Now from here, I will just make two diagrams. One will be for capital M. This force T is pulling this capital M, and frictional force F is acting backwards. The whole system is moving with acceleration A. And the small block with mass small m is going downwards, tension is acting upwards, and acceleration is downwards because the whole system is downwards. Okay, I'll try to write down the equations for both. So for this one, since it is moving rightwards, so the net force on the system will be T minus F. That will be equal to, net force is always equal to mass into acceleration. Okay, I'm not using any different formula. It is same as F net is equal to mass into acceleration. Okay. Similarly, I'll go in the other one also, and I'll write mg minus t is equal to mass into acceleration. Now just have a look at the second equation, and if there is any doubt to anyone, let me know. Why it is written mg minus t? Can anyone tell me why it is written mg minus t? Okay, the whole system is going downwards, so the downward force mg will be treated as positive. Okay, and that t is opposite of that. So mg will be positive minus t, and net force will be mg minus t, and that will be equal to mass into acceleration. Okay, is it clear now?
So T stands for tension, right?
T stands for tension.
So what does the, so can you explain again what tension looks like over here? It goes up or what?
Tension is always applied at the free end. Okay, like just imagine that if a string is means if you just cut the string over here, okay, then at this point there will be equal and opposite tensions applied like this. Okay, so one tension will be like this and the other tension will be in this direction, which will be because of that block, means which will be because of that mg.
Okay, so I think I got it.
This will be m, this is mg, and this is tension. It is always applied like this. So at this point you can see that both the tensions are equal and opposite. Okay, so equal and opposite means it will be applied like this. Are you using that avatar, Raghav?
So which one?
There's an option of avatar. Are you using that in Zoom?
No, so why?
Hmm. Suddenly there was one like different creature that was visible.
Ah, no, no, because I think it's because like it's too dark outside here, so I'll just turn on the lights.
No, it's okay. It's okay. It is
I
something
just
at
made this.
the. It is something at the back. Have you guys explored that avatar?
Ah, no, so this is just like the wallpaper. It's not avatar or anything.
Yeah, yeah, yeah. Okay, I thought that it is that. Okay, it is really.
So if avatar was this good, I'd use it, but it's not this good. It's like okay.
There are all animals in that. So once I was trying and all the animals, so I cannot use it. Yeah, this is not an avatar.
But there's one where it's like it's the character itself. So wait, yeah, there's one here. Okay, there we go. Is it working?
No, like this is the avatar.
Oh yeah.
Uh-huh.
The cool thing is like it does everything that you're doing. So
Yeah, yeah. Okay, so coming back to our question, there will be two equations. T minus F is equal to Ma and mg minus T is equal to Ma. I'll just write both of them once again over here. This was M, this was T, F was over here. So the net motion is towards the right. So T minus F is equal to Ma. Then the other block was moving downwards. So the downward force will be taken as positive, upward will be negative. So mg minus t is the net force. Acceleration is downward, so that will be equal to ma. Okay. Now from these two equations, we need A. We need acceleration. So I have to treat them like two simultaneous equations from where I can remove T, tension. Because tension is not given in the question. It is what we had introduced to solve. So I will just add these two equations. When I add, you can see that this t and minus t will be cancelled. So in the left hand side, I will be having mg minus f is equal to right hand side, it will be ma plus ma. That a will be taken common, so it will be m plus m On the other side, I have mg minus f. I can't do anything to that. So from here, I'll get the value of A as mg minus f over m plus m. That is the acceleration. Okay. So for now, you should be able to write down the equations, like equation 1 and 2, how it is written. Solving the equation is a different thing. Okay. So if there is any doubt in writing the equation, you can ask again.
So can you explain again?
Okay, whenever we write down equation, we always see the direction in which the system is going. Okay, so this whole system is going in which direction? Right direction.
Yes, sir.
That's why the acceleration is taken in this direction. So when it is going in right direction, by default, the forces in the right will be considered positive and forces in the left will be considered negative. So that's why the net force is T minus F. Is that clear?
Yes, sir.
So T minus F is the net force, and net force is equal to mass into acceleration. What is the mass of this body? Capital M. Okay. So mass into acceleration will be equal to net force.
Yes, sir.
Okay. Similarly, if you look at the next figure, this is going downwards. So the downward forces will be taken as positive. There is no rule who will be positive, who will be negative. You have to go with respect to the question. If it is going downwards, downward is positive. Okay. If it would have gone upward, then I would have taken upward as positive. So mg minus t, because t is the upward force, and that is equal to net mass, that is m, into acceleration. Now from these two equations, I can see that this is minus t and this is plus t. So if I add them, okay, let me do this step once again, so that calculation part will become more clear. T minus f is equal to ma, and mg minus t is equal to ma. This is equation 1. Equation 2, we are going to do 1 plus 2. In 1 plus 2, it will be t minus f plus mg minus t is equal to ma plus ma.
MA.
Now this t and this t will be cancelled. The net force on the left, but the net terms on the left will be mg minus f, and on the right it will be a times of m plus m. And that will give me a is equal to mg minus f divided by m plus m. Okay, still look at all these steps, try to write it down. If there is any doubt in understanding any part, you can ask again.
Okay, so I understand now. So I understand how you use those two equations to come up with this, but I still think it's kind of hard from the diagram to come up with these two equations.
I think the first one is simple because we know
No,
that.
so I understand these two, but like the first from the question itself, it's kind of hard.
Yeah,
Can you
it will take
Can you
time.
go back to the question?
It will take time, Raghav. Means you have to solve minimum 10 to 20 such questions. Then you'll get the real feel that now it is very easy for me.
Yes, sir.
Okay. So from the question, it is pretty much clear that the block kept on the table, that surface is going towards right. The block which is hanging is going down. And yeah, according to that, we drew the free body diagrams. And from there, we got the forces. And those two equations we will use to solve for A. So my answer will be option C. Okay, so for the namesake, it is an objective question, but you have to solve everything. Okay, you can cut down the steps if you're clear with it. But if you're not clear with it, initially you should solve each and every step like this. Is it done?
Yeah, I think I understood it now.
Madison and Raghav, is there anything
Yes, sir.
you are writing?
No, sir.
Okay, now I'll give you one situation. I want you guys to make the free body diagram. So this is a photo frame. Okay. This photo frame is hanged by on two nails like this. Okay, these are the strings. Considering that the diagram is exact means it is symmetric on both the sides. Okay, draw the free body diagram of forces applied on this frame. The hint which I can give right now is whenever we are drawing free body diagram, you can take an object as assume object as a point. It will be easy for you to think. Now, as a point means what? This photo frame, whatever may be the size of it, I don't care. It is just a point. On this point, there is one force acting from this, another force acting from this direction, and one force will be acted downwards because of its own weight. So this will be mg, this will be t because it's a string, this will be t, it's a string, okay, and that's it. In free body diagram, they're not asking us to solve, so we can leave it till here.
So in a free body diagram, we basically just show the forces acting on.
Yes, free body diagram is just a representative of forces, what all forces are applied on the body. Okay, is it clear?
Yeah.
Done, all of you? Last question. I have an inclined plane. Block is kept like this. There is a pulley system, and another block is kept like this. Now, if this block comes in contact with that inclined plane, that plank, things will be different. Right now, there's no contact. No contact means no friction. So there will be friction. Okay, both the masses are same. And we need to just draw the free body diagram for this system. So when I draw the free body diagram for that mass which is kept on the inclined plane, this will be T. There will be a force of friction acting downwards. Okay. Then this is mg, this is mg cos, and this is mg sine. So this time mg sine theta and f, both of them are acting in one direction. It is fairly possible. Because now force, that pulling force is T, the tension force. Okay, so these are the forces acting on a body kept on inclined plane, and the other one will be easy. This is mg acting downwards, T upwards. Okay, now if the whole system is in equilibrium, then I can say that T will be equal to mg sine theta plus f. Over here, T will be equal to mg.
Sir, how do you establish the direction of T?
Okay, direction of T is always considered by assuming that if you cut the thread, the string, then it will be upward over here and downward over here. Similarly, if you cut the thread over here, then it will be upward over here and downward over here, always. At any point from where you are cutting the string, tension will be equal and opposite. So we don't have to take the tension on this end. Okay, I'll just shade. We don't have to take tension for this. This we can leave. We have to just talk about the two forces, the two blocks.
Okay.
Yeah. There will be few more questions which we have to cover for free body diagram. In fact, now next week onwards, as the schools will start, okay, so at least for the next week, one more week, we will be doing as per what we are going, okay. Then as schools will start new topics, we will go as per them. Okay, most probably they will be starting with first unit, which is units and measurements. Then after 1 or 2 lectures, they may come to vectors. So if there is anything you are not getting it, you can ask immediately in the very next class, whenever we have a class. Okay, whether the topic is going on or not, you can ask. Okay.
Okay, sir. Yes, sir. So also for maths, like the last question we did, was it comparable to any of the HL questions we'll get, or they will be much harder?
Which question?
So like we did the test, right, for the maths sequences and series. Like those questions, are they like compared as easy as to normal HL questions, or they're harder, or they're like the standard?
Those are medium level questions.
Okay, so they're not very easy as well, right? They're medium level.
No, very easy questions will be like these are the terms, find the nth term,
Ah, yeah.
find the common ratio. Okay, like we did initially, if you remember.
Yes, sir. Yes, sir.
So those questions will have very less chances to be asked.
Yes, sir.
Okay.
But those were the standard questions, right? The ones we did.
Yeah.
Okay.
Those
so
are
that's
exam oriented question only. In fact, the resources which I am using, school
Yes, sir.
teachers make paper from there only.
Okay, sir.
So you may get the same exact copy pasted questions I have seen, what we do in class. Okay, there are teachers who just copy paste the question, so you may get the similar question in your, not similar, the same question in your exam. Okay.
Hopefully.
Yeah. Okay. So as of now, we are keeping the time tentatively at 5:30 only. It may be from 5 to 6, or it may be from 6 to 7. Whatever it is, I will inform in the group. Okay. I'm talking about next week because now schools are starting, so there will be some changes. Possibly for you guys, it will not be because you are at the actual timing only. But for other batches, other students, I have to set up the timetable. Okay. If there will be any change, I'll inform.
Okay.
Okay.
Okay. See you then. Bye-bye. And
Yes,
all the
bye,
best
sir.
for your first day of school. Madison, all the best for your placement test.
Thank you, sir.
Best of luck, man.
Don't get scared, okay? Just
Yes.
play it like football, no basketball, whichever sport you like.
Sure, sir.
Okay.
Thank
Okay. Bye.
Sir, can you, if you're free, please send me those questions. You said you can.
Sure. I'll send it now only. Okay, you want for quadratic functions?
Yes.
Okay.
Thank you, sir.
Yeah, okay, bye.